So, hello everyone. Thank you for being here for my presentation. So, I'm French. I'm Thomas. Well, this is my first time in Canada, in Quebec. My talk is in English, but I can speak French. Please excuse, as I'm French, please excuse my really broken English, even my broken French, I guess. So don't hesitate to switch language if you have some question. So let's start. So just before already starting, whoever in this room already heard about Hadoop? Oh, cool. A lot of people. Great. So we'll talk about Hadoop and security and pen testing Hadoop and common vulnerabilities on this framework. So first, I'm Thomas. I'm a French consultant in penetration tester and incident responder. I like to build some tools, InfoSec tools. So here's my GitHub. If you ever or will use any of my tools, just come say hello and we'll have a beer. So the agenda for today. So first, let's talk about for newcomers. I think there's not many newcomers to Hadoop today, but it is important to outline the security model, and then we will see how can you tune and how can you pen test an Hadoop cluster, and the last part there will be some conclusions, some high-level conclusions, so for defenders mostly. So let's start. So what is Hadoop? From definition, Hadoop is an open source framework that allows for the distributed processing of large data sets across the cluster using simple programming models. So it refers to what is called big data. What is distributed processing? It is based on the MapReduce algorithm, based itself on two functions, map and reduce, described in 2004 by two Google engineers in order to sort and index web pages. Here's the model. You can find easily on that picture that what does the MapReduce algorithm? It sorts and it allows for multiple nodes to perform the same task. Here, just to sort by color different stuff. So the simple programming model uses the MapReduce. You have a map function doing a job, and then you have a reduce function that merge all intermediate values with the same intermediate key. That's the point. If you understood this, you understand everything in Hadoop and in MapReduce. First slide. Then the open source aspect of Hadoop, like Linux in enterprise, you have Linux, which is open source and free, and you have distributors like Red Hat that sells you support and sells you distribution. In Hadoop, this is totally the same. You have three major providers: Cloudera, Hortonworks, and Mapper. The two first are the business is split between the Cloudera and Hortonworks. They have different models. I won't say too much things on it, but Cloudera use proprietary stuff and try to develop some high value added stuff. Hortonworks only packages only open source components. So technically, the license is cheaper for Hortonworks than Cloudera. And Mapper is doing Hadoop without Hadoop. Hadoop is, they are not really focused on Hadoop, but Hadoop is just a connector. Mapper does only data concentration, but Hadoop is just another connector. The common point between all distribution is the use of Hadoop core framework. Well, we'll see just after what is the Hadoop core framework. Hadoop is just doing only two things: store data and process data. And again, if you understood this, you understood everything about Hadoop. In real life, what does a big data environment looks like? The first thing, I hope with this presentation, I will demystify some stuff such as big data is fast. No, big data is not fast. You will see in the demos. I have a lot of demos just to show you some stuff. Big data is not fast. Big data, what is big data? Is a collection of technologies and methods to process large data sets. This is the best definition I can give about big data is behind and beyond the buzzword. Beyond the buzzword, big data is something, it's a collection of technologies that you have to use in order to process data sets, and you could not process such data sets without big data. That's the best definition I can give. In real life, what is a big data environment looks like? You have a lot of CPU, RAM, disk. On top of it, you put Hadoop core framework to support the data lifecycle in the platform. So in the lifecycle, you have different phases. That's nothing new. First, the acquisition. Here you will see a lot of modules 90% of this module are open source and free and comes from the Apache Foundation. That's, for you, maybe today, Apache is just a web server. For me, Apache is the main provider of big data stuff and open source technologies. So you have different modules like Flume, Kafka. Kafka is a renowned module for acquisition. Scoop again. Then you have storage. So storage in the Hadoop core framework means HDFS, Hadoop Distributed File System. We'll see just after what really is HDFS. Then for processing, what you want, so you want to process data in such environments. So you have a lot of modules. Some are really fancy, some are really old. Technologies keeps changing. Names are changing every 3 months, I guess. That's really disturbing, to be fair. When I entered this world, this ecosystem, Apache Spark is the most fanciest module. You can process everything in RAM instead of I/O, so it's faster and it's really fancy today. Apache Drill to perform some distributed SQL requests. Again, a fancy module. Then you have indexation. I guess for indexation, you already know about Apache Solr, Elasticsearch, Lucene, Oak, and so on. For consultation, which is really important, in the end, you don't process data for fun, you just process data for end users. So you have different modules, just known as Jupyter, formerly IPython Notebook. So it gives you an interpreter and fancy, again, sexy graphs all in the HTML page. You have Cloudera U, which is famous, Tableau, SAS, Platform, Splunk, which are proprietary stuff and legacy stuff, except Splunk, which is still rolling. Dataiku, which was a French visualization technology. And then for administration, each distribution has its administration module. You have Cloudera Manager, Apache Ambari for Hortonworks cluster, Mapper for Mapper. And then we have what? Security. So the first thing is you can see security, there's only 4 modules compared to hundreds of modules for everything else. And among these 4 modules, I could say that 2 are dead. So you just have Nox and Ranger are still surviving and great modules. They are not made for the same use case. And they are the only security solution for Defender, so live with it. Hadoop core under the hood, so you have Yarn, MapReduce, and HDFS. Yarn and MapReduce are job distribution and job schedulers across the platform. Yarn is a complex stuff. I could make a presentation only on Yarn security. To be fair, it's been like 3 or 4 years I'm digging that Hadoop stuff. I still don't master anything in Yarn because it's really way too complex. This is a complete operating system by itself. MapReduce, you saw it just before, is the job algorithm distribution for distribution. And for storage, everything is simple, just as in the Linux paradigm. Every data is a file, and every file is divided in multiple parts. You have 2 types of nodes in HDFS, some data nodes storing actual file parts, and 1 single active name node, which stores a mapping list of file parts and the location. So as you can understand, a single active means a single point of failure. That's true. And from few versions ago, Hadoop introduced a secondary name node passive for redundancy stuff. But you have to understand that if the name node is crashed, nothing works in Hadoop. Everything goes and everything works through a name node. Every time you request a file, it goes through the name node, which gives you the actual file location. So if you crash, if you DDoS, if you DOS the name node, you DOS the cluster. So far you can say, yeah, that's cool, really interesting, but really who uses Hadoop today and anyway? So you have I would say formerly only web giants, Criteo, Adobe, eBay, Yahoo. These are the actual numbers from the Hadoop page. But the thing you have to understand is that before, only web giants would have such capacity to process large data sets. Today, every company, banks, insurance, whatever you want, they want to perform and they want to process data like Google, like eBay. So classical companies, I would say, bank, insurance, do and will implement Hadoop clusters for their own needs. That's why it's really interesting for us, for attackers, pen testers, because you actually find Hadoop clusters on corporate networks in banks, insurance, retailers, and so on. That's not only for web giants today. So then the security model. The first thing you have to understand, the main thing about Hadoop security is there's no authentication by default. It is called the simple authentication. I'm just giving you 2 seconds to read the sentence here to understand if it is real actual security or not. So by default, simple authentication means you can pretend whoever you want. You just have to give a parameter saying who you want to be. You are that user, because you know that this is simple authentication. So at the roots, Hadoop haven't understood what authentication is. Simple authentication is by default. Genius stuff. Simple authentication equals identification equals you can be whoever you want on the cluster. Apart from any security ACL or whatever, if you have simple authentication, that's a game over. And that's, for you, it's 2 seconds to check if you are from the configuration file, if you are in simple authentication or in the sole proper authentication module foreseen and expected, which is Kerberos. They re-implemented a lot of stuff for Kerberos. Again, I could make a talk on itself on Kerberos and Hadoop. But if you don't have Kerberos, that's already game over on your cluster. That's the first point. You have to watch out because you can have Kerberos implemented, but on the core, but not on the interface, on the surrounding interfaces. You can have core on Kerberos and the surrounding still in simple authentication. So you have to check several values to understand if Kerberos is fully enforced or not. Then, for authorization, each module, you remember all the module I showed you. So for different, the hundreds of modules, each module has this authorization model. Again, for defenders, that's a pain. For instance, for HDFS, which is pretty simple and pretty at the root of Hadoop, it is based like Linux on the POSIX permissions, like UGO, user group other. And since Hadoop 2.5, HDFS also supports POSIX ACL, so you can have extended attributes that's for finer grain ACLs. Then let's take another example, Hive. What is Hive? Hive is the relational DBMS of Hadoop, like the MySQL of Hadoop. The authorization model is based on SQL verbs, select, update, create, and so on. So you have to set some ACLs on this verb. Again, defenders, you're welcome. So you need a third-party component to manage everything. You can say, yeah, I guess there's a lot of solutions to perform the same. No, there's only one solution, which is called Apache Ranger. This is the only serious product today. The bad news is if you don't have an out-on-works cluster, it is not expected by default. You have to install it by yourself. That's the point today, the point of operational security on Hadoop cluster. So Apache Ranger is pretty sexy and pretty nice, and that's a nice open source project. So you have ACL here, and you have another tab which is audit, which centralizes your logs, so you can perform some analysis on it. There are some other products which are called Apache Sentry or Cloudera Record Services, but to be fair, they are almost dead. Maybe even dead, I guess, and less user-friendly, so more error-prone. So as a security practitioner, you don't want this kind of stuff. Then for data protection, by default, you don't have any encryption in transit or at rest. But for in transit, you have, I won't detail also because this is a subject by itself, but you can have all your flows encrypted. That's a good starting point. Whereas TLS is not natively enforced, it is natively offered on most of web UIs, so you can enable it. By default, for the communication with the data node, you have a proprietary, open source proprietary specific protocol named DTP, Data Transfer Protocol, which involves 2 phases. You just look at the algorithm and make your own conclusion on it. The thing is, nothing is performed by default. Then for at rest, this is not complicated. This is really simple. You have different keys, but the thing is, for the cold storage, to prevent someone stealing their drive to be able to read it, you have HDFS transparent encryption from Hadoop 2.6. You have three keys, one for to encrypt the directory, one to encrypt the file, and one to encrypt the other keys. That's pretty simple. You just have to understand that it may sound complicated. I hope it's not, but everything relies on ACLs, on the KMS. Nothing new in 2017. So if you can poon, if you can attack, or if the KMS, which is a standard server, I'm not talking about HSM, if you can pawn that server, you have access to everything. It's not about cryptography, it's just about ACLs. You just have to understand it. And the core message here is, if you want to implement Hadoop, if you want to secure an Hadoop cluster, don't start with encryption at rest. This is, for a specific scenario, someone stealing your hard drive in your data centers. That's not the first scenario, the most expected scenario. So let's talk about practical stuff now. Let's map the attack surface. So you're connected, you're engaged for a mission, for a manda, like you say here. You want first to map the attack surface, so you're plugged into the corporate network and you have a list of URL and IP of your target. What do you want to say? First thing is you have to figure out which topologies your client is using. So from our experience, you have 3 topologies. The first one is the whole exposed on the corporate network, which can translate as no segregation, and I don't give a shit about network segregation. This is a common stuff. So here, everything is just plugged on the network. So if you are an attacker, you may be just on the same link. Okay, that's, as you can understand, there's a wide attack surface, and there's a high probability of illegitimately access anything. That's good for you, but that's not a good start for the company. Then you have a better approach. I would say less cost-effective than the first, but still from the security point of view, it is cost-effective. You just have only necessary end-user services exposed. So you have web apps. As I said, Cloudera, Jupyter, Zeppelin, which are data consultation stuff from a browser, that's it. And you just have, I haven't talked about EdgeNode today. EdgeNode is just a jump server. Do you know what is a jump server? For classical administration and network stuff, this is the best. We can also call this a bastion. So you have to authenticate on that server, and from that server, you can bounce on any server on the internal side. So an EdgeNode is the same for data scientists. Who are data scientists? People that are using Hadoop clusters. And they do need a console, a shell, an SSH to perform some requests and so on. So here, the network exposition is better. Just necessary stuff are exposed. You don't have data nodes and name nodes directly on the corporate network. So the attack surface is really reduced, and you must exploit some trivial or default credentials or web vulnerabilities, or I guess some outdated stuff on the EdgeNode, which can be a plain Linux or Windows server. So it is better for security. And then you have the highly segregated from the corporate network, aka I'm paranoid about security of Hadoop, and I don't want anyone to leak any file contained on the Hadoop cluster, which are most likely teras, hundreds of teras, like almost petabytes of data. So here it is even more complicated for attackers. You have to compromise first a real bastion, a Citrix, something you can just only have a keyboard and a mouse on it, and then you have the internal stuff of Hadoop, so the EdgeNode, the web apps, and so on. But so you can understand that this topology gives you a minimal attack surface, so your scenario will have the least probability. Then, so that's okay. You figure out your topology. You're starting your nmap scan. In Hadoop, there's a shitload of ports, and this is what you will see in this slide is a tiny example, the most necessary ports, but this is a tiny extract. So you have ports related to HDFS, to Yarn, and some old stuff from MapReduce version 1, which if you can find this kind of port, it's again good news for you because it means that the cluster is quite old, so quite outdated. So you better enable the vulnerabilities you will see here. That's a good news for you. So on the data node, on the name node, you commonly find this kind of stuff, which again I repeat is 1 or 2 servers, no more. Then for data nodes, which can be 100, 1,000, you have for HDFS several ports, again, to transfer some data. You have again some yarn and some old stuff for MapReduce port. So each port has a function. To be fair, from a network from a mapping point of view, you have to find that services because it gives you a nice web UI. You will see just after. This is pretty convenient. You have to find this service, and for the name node, for the data node, you have to find this service because again, it gives you a nice web UI. And because as you've seen, as I showed you in the first slide, there's a lot of modules. Among that module, not every module is interesting from a security point of view. Only few are really interesting, such as those one. So WebHDFS, you will see just after what is WebHDFS. Apache Nox, that's the same. Cloudera Manager, if you want to manage and to administer your cluster. Apache Ambari, the same. Apache Ranger, you want for security administration, which is another topic. Cloudera U, because it is an end user interface. And Uzi, because it's something related to job scheduling and job definition. So it can give you access to remote command execution from it. So you have to find that your web UI. Here, I can show you just now what is this web UI. So this is it. You have several technical stuff. So you can find here the version, the topology, I guess, in data nodes. You can find here, I just have, for demonstration purpose, I just have anything in a package in a unique virtual machine. But here you can find the capacities, and you can find how much capacity you can have on this cluster. That's really interesting. And here, you will see just after, but you can browse the file system. Because as I said, HDFS is a file system, just like Linux, but it is distributed. And you can parse and browse and everything. You can access any data. Here, I have a permission denied. You will see that this is not a border for you, but still. So you have to find this web UI. The other web UI are still a bit roots. You can least sexy web UI ever. Then you have technical stuff. You cannot perform anything interesting on this web UI, but it gives you a lot of information. They are meant to track jobs launched on the cluster. These are for debugging stuff, debugging and following your job, what is the status, pending, okay, successful, not or not. Other web UI, you have to find this kind of web UI. It gives you a lot of information about, if it is a name node or a data node and so on. To ease the pain, we developed some dumb fingerprinting scripts added in a headmap trunk that you can map easily, and you can find easily this kind of services just with the HTTP enum big nmas script. So it gives you this kind of answer, this kind of output, so you can easily see. Here just for one virtual machine, so it doesn't reflect the reality, but still you will find for each port what is the function of that service and where are you on the data node, name node, third-party stuff, I don't know. You also have some other scripts that we haven't developed for HBase and Flume existing. Then, surfing the data lake, it gets better. So you are a big data attacker, what do you want? You want data. How would you like to access it? Through a browser, because you're a lazy bastard like me. You want to use the WebHDFS protocol. What is WebHDFS from you? That's really simple. It's a way to access HDFS through a web browser. That's a REST API to access anything and to perform any action on the data lake. The data lake means the HDFS file system, the HDFS space, I guess. Where can you see some HDFS services? Several ports, several modules, always the same. You can call the API and access everything if it is in simple authentication mode, you'll see. And okay, now, if the cluster only enforces simple authentication, and you can see these kind of services, what you can do, you can spoof any user you want with the user.name parameter. That's not a bug, that's an authentication feature. You can specify where any user you want, and you will be that user because you are in simple authentication. That's easy as this. So let's have some demo times. So I'm just going back here. So you can see there's some permission denied, okay. I'm just browsing through the web UI, so that's not really convenient. I cannot perform anything. You don't see any parameter here. Let's call the true API. So I'm just taking this, and here, this is really simple. I want to access /user/HDFS repository and space, and the operation is list status. Okay, the permission is denied because I'm not really authenticated. I'm Dr. Who, which is the default user in Hadoop. I don't know why. If there's simple authentication, you can type what I'm typing and say, yeah. So the folder belongs to HDFS. That's plain Linux ACL, POSIX ACL. So I'll be HDFS. Okay. I can access everything. That's as simple as this. So you can find some files. So I do have a Hackfest file. You'll see the content just after. But here it works. So I can specify HDFS. That's as simple as this. From the HTTP version, that's it. We created a dump script named HDFS browser in order to list everything that, in simple authentication, it will automatically fill the user.name parameter and will give you a nice CSV list, CSV tree of the repository. Now, if you want to do the same through CLI, because Hadoop at the beginning and less and less, but everything was in CLI and you have native Hadoop clients, you can perform the same. You just have to export an environment variable, and that's the same. So let's see. Here I'm from the attacking machine. I can say Hadoop. Just let me check the syntax. Okay. That command we just try to display the Hackfest file. I haven't specified any username, and what does it say? It's a permission denied because I'm currently the root user of my Linux attacking stuff. I'm not the good guy. I'm not the HDFS guy. So okay, that's not a border. I just have to input Hadoop username equal HDFS, and ta-da! Hello Hackfest. So that's the same. Again, that's not a security vulnerability. That's a feature because you're in simple authentication. Let's move on. So with this kind of stuff, you're pretty happy because you can browse any data, any folder you want on HDFS, but you can do better. Remember, Hadoop is a framework to store and process data. Processing means executing some codes. Executing some codes for an attacker, it means I want to execute an interpreter or whatever I want. So if there are simple authentication and you can find the correct services, which are not the WebGFS one, which are which are named the IPC, Inter-Process Communication Services, you can execute freely any command on any cluster through MapReduce jobs. The question is, how can I specify a MapReduce job? I don't want to write any Java code because, like me, Java is a pain, Java is slow, and Java is ugly. So I would like to use, there's a tiny utility named Hadoop streaming. What's the function, what's the goal of the Hadoop streaming is to create and run MapReduce jobs with any executable or script as the mapper or the reducer. So I won't write any Java code. I just can input everything I want. So the command is here. So you just have to specify the path on your local machine to the Hadoop streaming jar. You have an input file, an output file, a mapper, a reducer. So technically, this command will launch a MapReduce job. This checks for the job results, because that's the trickiest part here is when you execute a task, you don't have standard outputs. Everything is written and read in files, so you have to cat some output files. You don't have the direct answer on SLAout, it doesn't exist. So you have to check that the output file is created, and then you have to cat the file through Hadoop fscat information. So that's okay, I can execute any command I want. That's a good point. But now I want to, for convenience, I want to execute a Metapreter or something from Metasploit. With the Meterpreter, you have session handling, which is really convenient again for as an attacker. You can use instead of the beancat etc password here, you can specify your own Meterpreter file, your own payload. But for some reasons, for unknown reasons, unknown clusters, sometimes Meterpreter doesn't work. So you just have to use a plain shell reverse TCP payload. It works the same, but you don't have the sexiest Meterpreter ever. So I won't explain you how to generate a payload. On your attacking machine, you just have to set up some stuff. So either Meterpreter or just shell / reverse TCP. So technically, this command, again, with the Hadoop streaming, you have a file. This time, you don't input a command. You have to upload the file first. So you have the file option to send your payload on the server. No, sorry. You have to, again, it will execute your payload, but there's a timeout value. You cannot execute things for eternally, I could guess. So you have to type the - background option because in order to start the job without finishing for its completion. Let's have a demo time. So you will see with this demo that no, big data is not fast. So here, I won't bullshit you. On your attacking machine, you set up your Metasploit stuff. So I use the reverse TCP payload. I'm just setting up my IP. I'm just starting. There's nothing interesting here. Here, I will launch that command, the command I showed you, more crafted because just to use to hope that the demo god will be with me. Just typing the config file. Inputting the jar file, Hadoop streaming, nothing new. Giving the version, giving the inputs. I have to give a non-empty inputs in order to process a job on Hadoop. That's it. So I'm giving the hello Hackfest file. I want to write the result in whatever file. I don't care, and I just want to, as a mapper, execute a MSF payload. I am an attacker and not a real data scientist. I don't care about reducer. I don't want, the full MapReduce algorithm. I don't care about sorting out and merging some keys. I don't care. I just want my Meterpreter to be executed. So I'm sending my payload here, and now I just have to wait. So I'm sending my job. Here I'm waiting. Let's hope for the reverse shell to come. What can I do just for demonstration purposes is just to show on the server side. Obviously, as an attacker, you don't have access to this kind of information, but just to monitor the execution, you will see that it is not really fast. And here, I just monitor that the job is already created. Okay, but still not processed. So I will go on the presentation. I would just come back in a few minutes and to see if my shell came or not. Just checking out now. No, still not. So the important thing to understand is that due to the distributed nature of a MapReduce job, MapReduce was invented to distribute some tasks among a cluster to use the most resource you can have. It is not possible to specify a specific target, a specific server, a specific node of the cluster you want to execute code on it. So you're just launching your job. You don't know where it will land anyway on one of the data nodes, but you cannot specify. That's a limitation that can be harsh in certain situations. So the prerequisites for the attack I showed you, and I hope I will have my shell just after, is to have a working and complete cluster configuration on client side on your machine. This is not a limitation, because if you request /conf from any web UI, I can show you here, any native Hadoop web UI splits the configuration. That's not a security problem. It is. I never found any secret here. It is not the place to store some secrets, some passwords. If you can find that, I'm really interested because it translates a real problem, but it's not. You're not supposed to find any interesting stuff in here. This is just for connecting and for topology stuff. Nothing really interesting. Oh, cool. So let's move back to our Meterpreter. Here, I received my job is I've been executed, and what do I have here? A shell. I'm As I am in simple authentication, I'm by default the Yarn user. Yarn is the operating system executing some tasks, so I'm this user. If there were Kerberos enforced on this cluster, I would be the user I would pretend to be. So I would need a kitab, a Kerberos kitab, and I would be that user. So here, Yarn has a lot of rights and privileges on the machine. So if you have this kind of user, you can perform, again, it's game over on the cluster. You just executed your metapreter and your stuff on the cluster, game over. So I just show you with it, who am I? So I'm Yarn, I do have a shell. That's cool. So for the configuration, either you input /conf on any web UI, or you can find there are some vulnerabilities on certain management platforms, such as Cloudera Manager. You can download. If you cannot, for some reason, see the service here, you can if you can see the Cloudera Manager, you can use that vulnerability in order to download the configuration file. So that's not the limitation as an attacker. As we want convenience, again, we developed a dump script again to retrieve a minimum configuration from for interacting with an Hadoop cluster. You will see at the end, we documented everything. So don't worry, you will have any script you want. The thing is, you need the 3 files in order to interact with the core site, MapRed site, and Yarn site in order to be able to execute your stuff on the cluster. You can say, okay, that's cool, but come on, who exposes such services anyway? Because as I showed you, you have to see some specific services, and you can be doubtful now just to say, yeah, but everyone is doing network segregation, and I won't find any internet cluster based on Hadoop. That's false. If you can input some shotgun stuff, just look at the results. I don't know if you can see, but with that simple port is the web UI I showed you just before. You can find a lot of stuff at least on Shodan. Again, and now Shodan is good, but we perform not a scan of all the internet. I would like to, but I have to. I will have to scan the entire internet for Hadoop cluster. But we quickly discovered almost 200 Hadoop clusters on the internet, freely accessible. So what do I mean by freely accessible? I mean that I can retrieve any data on it and execute anything I want on it. So, because why can I execute anything on it, on this cluster? Among the 185 clusters found on the internet, that's really a quick scan, the quickest scan ever. You can see the security authentication. So for the large majority is simple. Simple means nothing. Simple means game over. Simple means you can execute anything on it. You can execute your botnet. You can store some files, some terabytes of file on it. For 5 clusters, we found they were enforcing Kerberos, which is a tiny figure, but still a thing. And more importantly, on the 5 Kerberized cluster, 0 were enforcing Kerberos from end to end. Even on the Kerberos cluster, we could find that for HTTP and NTF races, they were in simple authentication. So still, again, okay, thank you. So still no security. And this is in the news. If you don't secure your Hadoop on the internet, there will be some guy deleting it or putting a ransomware on it. Encrypting petabytes of file does exist on the internet for open Hadoop cluster. So now another vector to attack an Hadoop cluster is to exploit trivial vulnerabilities on Hadoop cluster. Hadoop is coded in Java, is an open source project. Developers are not really sensitive to security, so what do you expect? Vulnerabilities. For a specific version, don't think that it is 10 years ago. No, this is really current. Under specific conditions, you have a nice privilege escalation vulnerability, a trivial, a ridiculous one. I will just show you just after. If the cluster use the property shell-based Unix group mapping as the group mapping feature, this is vulnerable to that CVE. That core function is called for each user action on the cluster. So when you want to add to download, to upload a file, to execute some stuff, it will ask first that function if you are the right user or not. That right user is that function. The shell-based Unix stuff is vulnerable. There's another implementation which is based on Java native interfaces. So a C code compiled in an ELF binary is not vulnerable. Can you spot the vulnerability here? So you have a command named HDFS group something, and the something is the user. No escape. So if you are an unprivileged user, you type that command is executed as HDFS. HDFS is not the root user on the Unix system, it's the root user on a Hadoop file system, which is even worse, to be fair. So with the HDFS user, you can access everything and perform anything you want. So here, I was an unprivileged user, and I'm going to be HDFS. So remember, HDFS is the real root user of the file system. We are not the vuln finder, we just documented the exploit. Even though Apache Hadoop is open source stuff, they are not really fair on documenting some stuff. So we wanted to document this. Let's have a demo. Now, now that you have your shell, I will just here, make it here for convenience. I'll be a plain user, Toto, no privilege ever, nothing, I cannot perform anything. I'm not root, I don't have anything, yes. With just that command, I'm triggering the vulnerability here. I will try to see which user am I. So you recognize the exploit I showed you just before. So let's check. Am I HDFS? Yeah, I am HDFS. I was Toto, and I have the privileges of HDFS. This is ridiculous. Is that clear to you? The most ridiculous vulnerability ever, I guess. So, as you would say, okay, so your condition was to be on shell-based Unix group stuff. Okay, but it is not the default value in the documentation. So on the internet, I wouldn't find any cluster with it. It is not the default stuff, come on. Again, some figures from our own study showed that if you're on purple, you are vulnerable to this flow currently. So you have some real figures, and I don't know why, I cannot explain why there's 1/3 of the found stuff which is using not the default value. I don't know. Then you still have, if you are not, if this kind of vuln is not sufficient, you have to attack third-party modules. Apache Ranger security module, the only security module ever vulnerable to this complicated vulnerability in 2016. So for post-exploit stuff, you can dump user credential. Okay, thank you. You can dump user credentials. That's good, but not really interesting. Or just dump the session cookies and steal and impersonate the people. So that's better. I don't have to crack anything. I don't want to spend energy for the planet, to waste energy for the planet. So just reuse the cookie. Again, Apache Ranger is a security module. For Cloudera U, another vector which is very interesting. Most of the time, an edge node is deployed for, as I said to you, data scientists to access the cluster. Most of the time, Cloudera U is installed on the edge node, which is a wrong design consideration, because there are still unfixed vulnerabilities for Cloudera U. You will see, I'm not even reading this. You can steal any cookie of any people on Cloudera U, any user, because the u.ini configuration file is readable for anyone. So in this kind of file, you have databases credential. In this databases, what you will find, again, session cookie. I think it's related to Python Django. It's not even related to Cloudera U, I don't know. Maybe it's been 1 year I'm saying this, but maybe this is a 0 day in Python Django for the storing, because the first vuln is okay, not to read the file forwarder for the u.ini configuration, but the second one is to store the cookie. I don't understand why people store session cookie in databases. I don't understand. So still, you can spoof any user stealing his cookie, and Trust me or not, neither Cloudera officially answered on these vulnerabilities nor fixed them. Mitigation, unset the read for other u.ini permission, okay? And more importantly, do not deploy Cloudera U on an edge node. Just not because I'm not bullshitting you, I'm just showing you from the shell here. Oh, the shell terminated, okay. I'm just, will input it here. It's not a made up vulnerability. The u.ini file is still readable for anyone. So here you can find some passwords. I think it's in the beginning. Yeah, you do have a lot of stuff on it. So still unfixed. Okay. And last but not least, our most elite attack is that command. If I can understand, it works every time. Most of the time, it works every time. We are searching for GitHub file, for Kerberos files, which are readable for other. And in real life, it gives you that kind of results. So you don't have to exploit anything, no bullshit, no shit I've been showing you just before. Just type that command, and you will have any access to the entire cluster. So mitigation, this is more like education. Do not make your user owner of their home directories, because they will share some stuff. They will shmod 777 stuff, and tell people Kerberos file and Kerberos GitHub is like a password file. No read for other, please. So just for that command, you have to input it. You can find this kind of result on local system, and also on HDFS system. For HDFS, the command is the same, because here I'm showing you here. You have an Hadoop fs find command, which uses the same syntax as Linux. So please type that command in local and also on HDFS. You will have some incredible results. So I hope to have encouraged you to join us in the bandwagon to start hunting for vulnerabilities. Deploying an environment could be a pain. Please use a prepackaged, as I'm using here, a prepackaged Hadoop environment. Just use some either Cloudera Kickstart or HGP Sandbox or Mapper Sandbox. Everything is packaged in a unique virtual machine. You don't need teras or whatever. It's just a simple virtual machine. You need like at least 5 gigas of RAM, because there's a lot of stuff inside. But use this kind of environment if you want to start to practice and to train yourself to pen test some Hadoop stuff. Everything I've been talking today is already published on our GitHub, corporate GitHub. So even more than vulnerabilities, we are documenting techniques and procedures with intelligible words and not only scripts. We are eager for your feedback, and I hope you like the vulnerabilities. I'm just taking 2 minutes for the conclusion. Hadoop, what is Hadoop? Hadoop is a technology not built about open security. There's a lot of insecurity by default, no authentication, no encryption, nothing. The ecosystem is fragmented. Apache Ranger, you can have Apache Ranger, the sole security solution, only if you have an Hortonworks cluster. That's a pain. There's a relative immaturity in secure development, even in security modules. Remember the SQL injection in Apache Ranger, the trivial one. And there's a complex operational security, because mostly people, even if you Kerberos, even if you do your job as a security practitioner, people will misuse Kerberos GitHubs because they don't know how to behave with Kerberos GitHub. So they will read for other everything. As an attacker, with a simple search find command, you will find any read for other GitHubs. That's a pain. Some wise recommendation if you want to start securing your cluster, Hello Defender, Kerberos your cluster first, and remove all simple authentication, HTTP, core, anyone. Reduce service exposition. Just don't use the all exposed on the corporate network topology. Don't give free shells, because if, for certain products, there are some read for other configuration file, that's a pain. Don't deploy application on edge node. An edge node is just a simple bastion jump server, nothing installed on it, no application on it. Prevent and detect permission misuse on Kerberos GitHubs, hello cron jobs, and try to harden component and patch your cluster. That's not a simple task. Thank you for your attention. I hope it pleased you. I'm open to questions. Thank you. Do we have some questions? Okay. Thank you.